Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking it up from the topic of straight lines, and we are continuing our series of questions on JEE Advanced. So today's question we are taking this up from the year 2021. And here if I talk about the question, we have been given that two lines L1 and L2 are given by x root 2 plus y minus 1 is equal to 0. And the second line L2 is x root minus 5. So these are the two equation of lines given. And then we have been told that C is the locus of point P, or I should say locus of product of distance of point P from L1 and distance of point P from L2 is equal to lambda square. So that is given to us again, that this product of the distances is equal to lambda square. That gives us the equation of the curve C. Then we have further been told that once you find the equation of curve C, this line y equal to 2x plus 1 meets the curve C at points R and S. And we have also been given that distance of this point, or distance between the points R and S, is equal to under root of 270. So with these conditions, we have been asked to find the first part of the question, that is value of lambda square. And there are four options given to us, that is 4, 9, 25 and 8. So we need to figure out which out of the four options is the correct one. Further, we have been also told that perpendicular bisector of RS, so whichever is the perpendicular bisector which I draw for RS, that meets again the curve C at two distinct points, that are R dash and S dash. And further, we have been also told that the square of this distance between R dash and S dash is equal to D. So D is given to us as distance between 2 points R dash and S dash. So we have to also find the value for this D which is given. And there are again four options given for the values of D. The first option which was 440 by 7, 40 by 7, and the last option given was 6. So we need to figure out the answers for these two questions. Now let's see how do I solve this idea. So first thing we will be using here is the concept that distance of a point P, let's say that point P is x comma y, from the line ax plus by plus c is equal to 0. That distance is basically given by mod of ax plus by plus c upon root of a square plus b square. If that point P is, let's say, x1 comma y1, then we are just substituting that coordinates x1 and y1 which are of the point. But here let's take, instead of x1 y1, let's take P as x comma y. So we will have the equation of curve C also as in terms of x and y. Now if I want to find the equation of this curve C first, I know distance of this point P from line L1. It is nothing but mod of equation of line L1 x root 2 plus y minus 1. I'm just substituting x and y from this points P, and under root of a square plus b square. So under root of root 2 square, which is 2, plus b square, that is 1 square, which is 1. So you get this distance becoming x root 2 plus y minus 1 upon root. Further, distance of this point P from L2, that is again equation of line L2, x root 2 minus y plus 1 upon root of a square plus b square, so root of 2 plus 1. So x root 2 minus y plus 1 upon root. Now we already have the condition here that we have been told product of these two distances. So product of distance of P from L1 and distance of P from L2. That product is equal to lambda square. So if I have this product in the mod, I get x root 2 plus y minus 1 upon root 3 into mod of x root 2 minus, if I take out common, you get y minus 1 upon root 3. That is equal to lambda square. So you get this in terms of a plus b and a minus b. That makes it a square minus b square. So x root 2 square minus b square upon root 3 into root 3, that is 3. That is equal to lambda square. So you get the equation of curve that makes it x root 2 the whole square is 2x square minus y minus 1 the whole square is equal to this entire thing is. So I have this equation of curve with me now, that is equation of the curve C, which is there, which was given to us as locus of product of distance of P from L1 and distance of P from L2. So we have this equation of curve C here. Now we have also been told that one equation of line y equal to 2x plus 1. This intersects the curve C at points R and S. Right? So basically, let's say our curve example C would look something like this, and the equation of line is 2x plus 1. That intersects our curve in 2 points R and S. So if I want to find the intersection points R and S, I can just solve these two equations, that is equation of curve C and equation of line, simultaneously to get x and y. Whatever coordinates of x and y we get, that becomes our coordinates of R and S. So if I just understand here, I can write this 2x as y minus 1 again. So instead of y minus 1, if I substitute 2x in this equation, the equation turns out to become mod of 2x square minus y minus 1. Instead of that, if I write it as 2x, that is equal to 2x the whole square is equal to 3 lambda square. So you get this becoming 2x square minus 4x square, that is mod of minus 2x square is equal to 3 lambda square. So if I take the mod, you get 2x square is equal to 3 lambda square. From this, you understand that x square is 3 lambda square by 2. Taking square root on both sides gives you x is equal to plus minus root 3 by 2. So you get the x coordinates of points R and S. If I now want to find out the y coordinate as well, I already know that it should satisfy both of these curves. So if I put the x coordinate in this equation of line to get y is equal to 2x plus 1. So y is equal to 2 into plus minus root 3 by 2 lambda. So if I solve this, I get further 2 goes inside, becomes 4. So that makes it plus minus 2 ones are 2 twos are root 6 lambda plus 1. So you get the two coordinates, that is R and S. So R, if I take it as a positive, it becomes root 3 by 2 lambda. And from here you're getting 1 plus root 6 lambda. And the other coordinate S minus root 3 by 2 lambda and 1 minus root 6. So you have these two coordinates now with you. Now you just, if I tell, let's say this is x1, y1, this is x2, y2, I already know that distance between R and S is given to me root of 270. And if I write the distance formula, it is nothing but root of x2 minus x1 the whole square plus y2 minus y1 the whole square. It's equal to root of 270. Squaring both the sides gives me x2 minus x1 the whole square directly. So the square root gets removed. If I write x2 minus x1, it is root 3 by 2 lambda minus root 3 by 2 the whole square. Here I get y2 becoming 1 plus root 6 lambda minus 1 minus root 6 lambda. The whole square is equal to 270. If I solve this further, becomes 2 times root 3 by 2 lambda the whole square. Here 1 and 1 gets cancelled, you get 2 times root 6 lambda the whole square is equal to 2. If you further solve this, 2 square is 4 into 3 by 2 lambda square. 2 square is 4 into 6 lambda square is equal to 2. So you get this 6 plus 24, that is nothing but 30 lambda square is equal to 270. If I solve this further, you get lambda square is 270 by 30. Zeros cancel, 3 ones are 3 nines. So you get the answer for the first part of the question, that lambda square is 9. So you get the option B as the correct one here. So option B is the correct value for the first part of the question, which is lambda square. That is, lambda square's value turns out to be. Now, if I further see the further part of the question, it is told to me that just find the perpendicular bisector of RS. So we need to find the equation of line which is perpendicular bisector of RS that intersects point C again at R dash and S dash. So let's try to find the coordinates R dash and S dash first. Let's do. So let's find equation of the perpendicular bisector of S. Now we have our points R and S here, and we need to find the perpendicular bisector of this RS. So let's find this equation of line. For equation of line, we just need the slope and we need one coordinate, that is this coordinate. So since it is a perpendicular bisector, this point, let's say if I take it any point, let's say E. So E is nothing but midpoint of R and S. So E basically becomes sum of x coordinates of R divided by 2 and sum of y coordinates of R and S divided by 2. Sum of x coordinates of R and S, if I add them, you get root 3 by 2 lambda minus root 3 by 2 lambda upon. And if sum of y coordinates I already know now, that is also equal to 1 plus root 6 lambda plus 1 minus root 6 lambda. So this gets cancelled out, you get this becoming 0. This gets cancelled out, 2 by 2 exit 1. So you get the equation or coordinates of the midpoint, that is 0, 1. Now if I just want to find the slope also, so if I find the slope of RS, that is equal to y2 minus y1 upon x2 minus x1. So we can just find the slope here by y2 minus y1. So 1 plus root 6 lambda minus, so 1 plus root 6 lambda minus 1 minus root 6 lambda upon x2 minus x1, which is root 3 by 2 lambda minus root 3 by 2 lambda. So you get this becoming 1 plus root 6 lambda minus 1 plus root 6 lambda upon this becomes 2 times of root 3 by 2 lambda. So 1 and 1 gets cancelled, you get 2 times of root 6 lambda, and this is 2 times of 3 by 2 lambda. Lambda gets cancelled, 2 gets cancelled. Root 6 you can split as root 2 into root 3 on root 3 by root 2. 3 gets cancelled, so you get the slope of RS as 2. So whatever is the perpendicular line to that, the slope will become negative reciprocal. So slope M for the equation of perpendicular bisector line becomes negative reciprocal of 2, that is minus half. So you have the slope of perpendicular bisector also, that is minus half, and you also have the coordinate here, so you just find the equation of line. So equation of line perpendicular to RS becomes y minus y1, that is 1, is equal to minus half x minus. So you get this becoming y equal to minus half x. Now, once you have the equation of line here, y equal to minus half x plus 1, we know that this equation of line also touches curve C. So this is the equation y equal to minus half x plus 1. This also, it is given that this also touches the curve C at points R dash and S dash. So now let's try to find the two coordinates of R dash and S dash. Equation of curve C was known to me already, that was mod of 2x square minus y minus 1 square. So mod of 2x square minus y minus 1 the whole square in mod is equal to 3 lambda square. We already know now the value of the lambda square, so that is 9. So just substitute that. We get this equation of curve becoming 27. So equation of curve C is this. Now we have been told that this equation of curve C and this equation of line has the intersection points at r dash and s dash. So let's try to find the coordinates of r dash and s dash. From this equation of line, we have y minus 1 is equal to minus half x. So if I put y minus 1 is equal to minus half x in this equation of curve C, the equation of curve C becomes mod of 2x squared minus half x squared. So minus half x squared turns out 1 by 4x squared is equal to 20. So you get this becoming 7 by 4 x squared is equal to 27. So if I solve this further, x squared becomes 27 into 4 by 7. So x basically becomes 27 into 4. That is, if I write this, let's solve this further. So I can write this as 3 into 9 into 4 upon 7. So if I want to find the square root, it makes it plus minus. Root of 36 is 6 and you get root 3 by 7. So you get the x coordinate of points r dash and s dash. Now if I try to find the y coordinate as well here, y becomes 1 minus. So you get 1 minus half. X, we already know it's plus or minus 6 root 3 by 7. So you get this becoming 1 minus half into 6, or this makes it 1 minus plus, so 1 minus plus, and half into 6 makes it 3 root of 3 by 7. So you get the equation, or I should say the coordinates of r dash and s dash. R dash makes it 6 root of 3 by 7, and you get 1 minus 3 root of 3 by 7. S dash becomes minus 6 root of 3 by 7, and you get this becoming 1 plus 3. So you get these two coordinates. Now you just have been told that you have to find the square of the distance between the points r dash and s dash. That is equal to d. So let's try to do that. Now I already know distance d between r dash and s dash is given by root of x2 minus x1 the whole square and y2 minus y. So distance, we have been told that distance between r dash and s dash is nothing but d, small d. But then we have also been told that capital D is given by square of the distance between r dash and s dash. So if I want to just find the square of the distance between r dash and x dash, it's just finding the difference in the x coordinate square and the difference in y coordinate square. That when sum gives us the capital value of d which is asked to us, that is square of this distance which is asked to us. So x2 minus x1, if I try to find out, I get that becoming this minus this, so x2, let's say, and this is x1. So it becomes 6 plus 6. So it basically becomes 12 root of 3 by 7 the whole square plus y2 minus y1. So 1 minus 3 root 3 by 7 minus 1 minus 3 root 3 by 7. 1 gets cancelled out. You get here, after solving, 12 square, which is 144 into 3 by 7 plus. This becomes minus 3, which is 6. 6 square is 36 into 3 and by 7. So you get this becoming 144 plus 36, 180 into 3 by 7. That makes it 5. So you get this value or answer for the capital D which is asked to us as 547. If you see the option that matches here with the question which is given to us as option C. So for the second part of the question which is given to us, the option correct which is present is option C. C is the correct answer. So we just found out the equation of line for perpendicular bisector. We solve these two equations of line and the equation of curve C simultaneously. to get points r dash and s dash. Then we just found out the square of the distance between r dash and s dash. That was capital D, and that came out to become 540 by 6. So you get the answer here for capital D as 540 by 7, which matches with the option. I hope you have understood how to solve this type of questions which deals with the equations of lines here. I'll see you again tomorrow with some other question from some other topic. But we are going to continue our series of questions on JEE Advanced. So please do like, share and subscribe to my channel. Also, do share these videos with your friends also who are involved in this preparation of JEE Advanced. So they can also take the benefit from these questions which we are solving. Thank you.